Okay, so these notes are going to be about systems of linear inequalities. We actually have already done just regular linear inequalities, so today we're adding in a system of that. So what a system of linear inequalities is two or more linear inequalities that are graphed together. So I'm going to give you some time to write that, but again, two or more linear inequalities that are graphed together. So we're going to be graphing two at a time. That's the most we will actually do is two at a time. So again, a system just means it's two or more. In this case, we're doing linear inequalities that are graphed together. The solution to a system of linear inequalities is where the solution is the overlapping region of points that satisfies both inequalities. So yesterday, you'll remember that we were shading. Today, we're going to be shading for one, then we'll shade for the other, where those two things overlap is the actual solution. So again, the solution is the overlapping region of points that satisfies both inequalities. All right, so starting with number one as our example, the directions say graph each system of a linear inequality to show all possible solutions. So we're going to graph both of the inequalities. Where their solutions overlap is going to be our actual answer. All right, so we'll get started. I'm going to zoom in so I can graph a little bit easier on this. So starting with number one, both of those are already in slope-intercept form. So in y equals mx plus b, y equals mx plus b, so we can just start by graphing. So starting with the first one, y is greater than negative x minus 1. So remember, we start with our y-intercept. So when y equals mx plus b, our b here is negative 1. So we're going to put a point at 0, negative 1. I'm also going to label that, so 0, comma, negative 1. From there, I rise and run using my slope. So my slope is negative nothing. That's actually a negative 1. So if you need to add in a 1 right there, that's negative 1. So remember, our slope is rise over run. So in this case, that's negative 1 over an imaginary 1. So we're going to go down 1. So to rise negative 1, we go down 1, right 1. So we're going to go down 1, right 1, and put a point. Down 1, right 1, down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1. So we went one direction by going down and right. So the other option is to go up and left. So again, up then would be a positive 1. So to make this negative, you have to go left 1. So we're going to go up 1, left 1. Up 1, left 1. Up 1, left 1. Up 1, left 1. Over and over again until you can graph this whole line. So there are all of the points for this. I'm going to label a couple of more. So I try and do the ones at the end just because they're out of the way a little bit. So this is going to be 1, 2, 3, 4, 5, 6, 7, negative 1, 2, 3, 4, 5, 6, 7, 8. So 7, negative 8 is this last point over here. Make sure you label at least 2 coordinates. All right, so we're going to draw that line. So I'm going to draw a line here through each of those points. Okay. And I didn't say this before, I should have. This is greater than, so that means this line is actually going to be dashed. So I'm going to erase just a little bit. I want to erase and change this to a dashed line. So let me go back and fix that again. So a dashed line instead of a solid line like I had drawn. So a dashed line, so remember, points on the line are not solutions. So 0, negative 1 would not be a solution. 7, negative 8 is not a solution. And then we're going to shade greater than. So this says y is greater than. So greater than, we shade above. So that is all of this area. I'm going to change my color here. So I'm shading all of this area would be the solution to that inequality. So now we're going to graph the second one. So our second inequality, again, is already in y equals mx plus b. So we're going to start at negative 5 on the y-axis. So negative 1, 2, 3, 4, 5. So 0, negative 5. All right. And then our slope for this one is 1. That is a rise of 1, run of 1. So in front of that x, there's an imaginary 1. So this rise over 1 would be 1 over 1. So we're going to go from here, up one, right one, up one, right one. So over and over again, up one, right one, up one, right one. You could also, instead of going up and right, you can go down and left, down and left, down and left. So I'm going to label this point out here as going to be 8, 3. So I have 2 points, 0, -5, 8, 3. I'm going to draw my line. Again, this time, this symbol right here tells me that it is a dashed line. It doesn't have the equal to, so it's a dashed line. So this way I don't mess up like I did last time. So dashed line. And we're going to shade less than means below the line. So I'm going to change my color here again. So I'm shading below the line. So that is all of this. So basically, when you graph two lines, you kind of create 4 sections on the graph. We have this section and kind of in the top right, this section over here, kind of in the bottom left, this section down here, and then this section towards the right-hand side. Where they overlap, the shading is the solution. So up here is just orange, down here is just pink. Right here in this section between the purple and green line is where those overlap. So I'm going to use a highlighter to show you where those overlap. So those overlap in this section right here. I don't know if you can see that highlighter, but it's bright yellow. So that would be the actual solution. So where they overlap is the solution to the system. All right, so let's look at another example. So we're going to go to number 2. So number 2, also both inequalities are already in y equals and y equals, so we can graph just by hand. So on the first one, we're going to start at our y-intercept, which is at 7. So we're going to go to 0, 7, put our point, so 0, 7. From there, our slope is 1 over 3. Rise 1, run 3. So from here, we're going to go up 1, right 1, 2, 3. We can only do that one time. So instead of going up and right 3, we can also go down and left to continue this line. So down 1, left 1, 2, 3. Down 1, left 1, 2, 3. All right, again, it's not equal to, it doesn't have the equal to, so it's going to be a dashed line. So we're going to draw a dashed line for this. Okay, so there's our dashed line, and we're shading y is less than. So less than is below. So we're shading less than. I'm going to use a highlighter this time just because I don't want it to there to be too much. So we're shading below this line. All of that here would be in the solution for that inequality. So now we're going to graph this second inequality. Y is greater than or equal to -x plus 4. So we're going to graph that one by starting at 4. The y-intercept here is 4. So we go to 0, 4 on the y-axis. So 0, 4. We're going to use our slope, which is negative. Again, that's an imaginary 1, so -1 over 1. So we're going to go down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Or we're going to go up and left also would be another option. This time it is equal to, so this time it is a solid line. So not a dashed line, but a solid line. So I'm going to draw a solid line through all those points. Okay, so there's my line. It's not perfect, it's pretty good. And then we're going to shade. So this one is shaded y is greater than or equal to. So again, I'm going to use a highlighter. I'm going to use a different color highlighter this time. So I'll use, let's see what gray looks like. So greater than or equal to tells me to shade above this line right here, this solid line. So greater than or equal to then would be above this line. So we're looking for where do those two things overlap. So again, this should break it up into 4 sections. So we have this section up here at the top, which is just gray. Over here, which isn't shaded at all. Down here, which is shaded orange. And then in this section to the right, that is gray and orange. So that is our actual solution. So I'm going to use a different color, let's say green. And this would be our solution area. So all of this area is where those two colors, orange and gray, were overlapped, and now I've colored them green. All right, so we're gonna do number 3, and then I'll let you practice. So number 3 is different because the first inequality is not in y equals mx plus b. So to graph by hand, you have to have it in slope-intercept form. So we've reviewed this several times over the last few days, but I just want to make sure we understand how to get this to y equals mx plus b. So we have x minus 4y is less than or equal to 24. So first thing is we need to get the x to the other side. I'm going to go ahead and add a 1 on that x. So to get x to the other side, we do the opposite. So we would subtract 1x. 1x. When we do that, these cancel. That's what we wanted to happen. We're left with negative 4y is less than or equal to negative 1x plus 24. We can't actually subtract 1x from 24 because they're not like terms. 24 doesn't have any x's. So we just bring both of them down and always bring down the x part first so that way it's in mx plus b form. The last step then is to get y by itself. So we need this negative 4 off of the y. So we do that by dividing by negative 4. The most critical part where a lot of students mess up is right here when you divide by a negative, which we are, this symbol right here flips the other way. So this is going to become greater than or equal to. So just because we divided by a negative right here, this symbol goes the other way. So this is going to become y is greater than or equal to, and we just simplified. Negative 1 divided by negative 4 is positive 1/4 x. 24 divided by negative 4 is minus 6. So now we can graph that equation or inequality. The other one is already in y equals, so we can graph it as well. So at this point now we're just graphing. So the first one, we're going to start at negative 6 is our y-intercept, so 0, negative 6. So I'm going to label that 0, negative 6. From there, we rise and run using our slope. So our rise is going to be 1, our run is 4. So we're going to go up 1, right 1, 2, 3, 4. So up 1, right 1, 2, 3, 4. Up 1, right 1, 2, 3, 4. We can also go down 1, left 1, 2, 3, 4. Down 1, left 1, 2, 3, 4. So I'm going to label this point down here as negative 8, negative 8. Right? It is going to be a solid line. This equal to right here tells me that this line is solid. So I'm going to use my app here to draw a straight line for us. So there we go. There's our line. All right, and then from there we're shading greater than. So greater than means we're going to shade above this line. Remember, you always want to use this symbol. If you use the one from the problem, you might do it backwards because you haven't flipped that sign yet. So we flipped our sign, so now we're going to shade greater than. So again, I'm going to use a highlighter to do this. So greater than this line is all of this above here. Be careful with how much you highlight because you still have to graph another line. So you don't want to color too much. Otherwise, you're not going to be able to see to graph your other line. So just be gentle with your highlighting. Okay, the other one we're going to graph is already in y equals mx plus b. So we start at our b here, which is positive 1. So that's the y-intercept at 0, 1. So I'm going to put that point, 0, 1. All right, and then our slope here, our m is 2. That's 2 over 1. So we're going to rise 2, run 1, both positive. So rise 2, run 1 to the right. Rise 2, run 1 to the right. Rise 2, run 1 to the right. Or down 2, left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. Again, we have an equal to. If it is equal to, that means it is a solid line. So we're going to draw a solid line for this one. There it is. I'm going to label one more point. I have 0, 1, so I'm going to label this other one here on the right-hand side, this far one right here. So that is 1, 2, 3, positive 1, 2, 3, 4, 5, 6, 7. So 3, 7. All right, and then the last thing is which way do we shade for that one? So this says y is less than. So less than this line is going to be shading below. So we're going to shade below And then we're looking for where, in this case, do my pink and blue overlap. So you can see up here is just pink. This little section down here doesn't have any. This one on the bottom right is just blue. And then this section right here, between this black line and this green line, this is all the shaded area. I will also say that this point right here, any point on this line and any point on this line would be in the solution because they're both below this one and above that one. So any points on the line, because they're not dashed, they're solid lines, would be equal to as well. So all of this area right here, this now darker blue section, would be a solution. So all of this area right here. So you might want to do that with a different color or just do it a little bit darker, but all of this section right here would be the solution to this system. Okay. All right, so hopefully that helps with those notes. We'll continue this in class. So.